This is lecture number 2 of chapter 5, that is elasticity and its application. First of all, we are going to study is what determines price elasticity. To learn the determinants of price elasticity, we look at a series of examples. Each compares two common goods. In each example, suppose the prices of both goods rise by 20%. The good for which quantity demanded falls the most in percent has the highest price elasticity of demand. Which good is it? Why? What lesson does the example teach us about the determinants of the price elasticity of demand? Here we take different examples to illustrate the different types of elasticities. So example number 1 is breakfast cereal versus sunscreen. The prices of both of these goods rise by 20%. For which good does quantity demanded drop the most and why? A breakfast cereal has lots of close substitutes, for example Cap'n Crunch, bread, etc. So buyers can easily switch if the price rises. And on the other side, sunscreen has no close substitute, so consumers would probably not buy much less if its price rises. And the lesson is price elasticity is higher when close substitutes are available. When there is something you can switch to, you tend to have a higher price elasticity, which basically means your response to price changes. You have a higher response to price changes when there is something that you can easily substitute for. Example 2 is blue jeans versus clothing. The prices of both goods rise by 20%. For which good does quantity demanded drop the most and why? For a narrowly defined good such as blue jeans, there are many substitutes like khakis, shorts, speedos, and there are fewer substitutes available for broadly defined goods. Can you think of a substitute for clothing other than living in a nudist colony? It means that there is no alternative to not wearing clothes. Are there any substitute for clothing? Not really. So the lesson is price elasticity is higher for narrowly defined goods than broadly defined ones. So the more specific you are, you can replace just wearing blue jeans by shorts, etc. But just clothing in general, there is less price elasticity. So you are looking at two alternative scenarios here. In the first, the price of blue jeans and no other clothing, so specifically blue jeans rises by 20% and we would observe the percentage decrease in quantity of blue jeans demanded. In a second scenario, the price of all clothing rises by 20%. We observe the percentage decrease in demand for all clothing. Perhaps people wear old clothing longer. However, in general, people are going to have to replace clothes that were out. And if blue jeans continually had a price increase over time, people would find substitute for blue jeans as well. Example 3 is insulin versus Caribbean cruises. The prices of both of these goods rises by 20%. For which good does quantity demanded drop the most and why? To millions of diabetics, insulin is a necessity. A rise in its price would cause little or no decrease in demand. And on the other side, a cruise is a luxury. If the price rises, some people will forgo it. A lesson of this example is price elasticity is higher for luxuries than for necessities. So necessities are necessary things you have to have. So there is demand for that is not going to change. And for luxuries, if price goes up, you just find a new luxury. So in case of insulin versus Caribbean cruises, or you can say the price elasticity is higher for luxuries than for necessities. Now comes example number 4. Gasoline in short run versus gasoline in the long run. The price of gasoline rises 20%. Does quantity demanded drop more in the short run or the long run? Why? There is not much people can do in the short run other than ride the bus or carpool. In short run, you're pretty much stuck kind of commuting. How you commute, especially in an area where you live. And in the long run, people can buy smaller cars or live closer to where they work. It takes whiles to sell your house and move closer, perhaps to work or to school, to come up with other alternatives like saving up to buy a hybrid cars. That's more of a long run deal. Therefore, the lesson here is price elasticity is higher in long run than in short run. In long run, everything is available, and in short run, there are something that have fixed cost and fixed investment. Now comes the variety of demand curves. Economists classify demand curves according to their elasticity. The price elasticity of demand is closely related to the slope of the demand curve. A flatter curve would cover more wide range of quantity on horizontal axis, and more steep curve would cover a less wide range of quantity on horizontal axis. And there is also a rule of thumb: the flatter the curve, the bigger the elasticity, and the steeper the curve, the smaller the elasticity. The next 5 slides present different classifications from least to most elastic. Here comes perfectly inelastic demand. One extreme case. A perfectly inelastic demand curve. There is no variation in quantity here, as you can see. There is no wide range in quantity. Quantity changes by 0% when price falls by 10%. The demand curve is vertical, this one, and consumers' price sensitivity is none. Its just elasticity is 0. In inelastic products like insulin, diabetic patients need a certain amount of insulin a day. They certainly do not want to take too much, but they have a minimum that they need, so that is inelastic demand. And if the quantity does not change, like in this case, quantity changes by 0%, that means that there is no change in quantity, then the percentage change in quantity equals 0. Thus, the elasticity is also 0. If we put these values of quantity and price in the formula that is given over here, that is price elasticity of demand is equals to percentage change in quantity divided by percentage change in price. So percentage change in quantity is 0% over percentage change in price is 10%. So 0% divided by 10 is equals to 0. So here the elasticity is 0. Now comes inelastic demand. Here the demand curve has a slighter curve which is really more realistic in real life, instead of the linear demand curve that we study in perfectly inelastic demand case. This one here, this is the demand curve. The demand curve is relatively steep. The consumer price sensitivity is relatively low. You can see the big change in price here did not result in huge change in quantity. Price falls by 10% and the quantity rises by less than 10%. The price fall is bigger. You can see from this point that there is, you can say, price falls is bigger than the quantity increases, uh, relatively inelastic. This one here, there is a small change as compared to change in price. So the elasticity is less than 1. So if you have the elasticity less than 1, you can say it is inelastic demand. So in this case, if you add these values here in the formula, that is price elasticity of demand equals percentage change in quantity over percentage change in price. Here the percentage change in quantity is less than 10% over percentage change in price, that is 10%, so it is equals to less than 1. You can see here that a fall in price is here, you can say 10%, but quantity rises less than 10%. So this change is bigger than a change in quantity. Price falls in a bigger quantity, you can say. There is a bigger change as compared to the change in quantity. So this type of elasticity is inelastic demand. Actually, this is showing inelastic demand, where a demand curve is relatively steep. Next is unit elastic demand. The elasticity is equals to 1. This is the intermediate case. The demand curve is neither relatively steep nor relatively flat. And buyers are neither relatively price sensitive nor relatively insensitive for price. This is also the case where price change has no effect on revenue. So price falls by 10% and quantity rises by 10%. By putting these values in this formula, that is 10% over 10%, we get 1, which means unit elastic. Here if you can see that if price falls by 10% from P1 to P2, then quantity rises by the same percentage, that is 10% from Q1 to Q2. So there is a same change in price and quantities. So here the price elasticity of demand is equals to 1. Next is elastic demand. Here demand curve is relatively flat, consumers' price sensitivity is relatively high, and elasticity is greater than 1. So we have a price change. The price falls by 10%, but the quantity rises by more than 10%. So there is significant reaction to the price change. As a demand curve becomes more horizontal, it covers a greater quantity and elasticity is greater than 1. So this is elastic demand. And if we put these values in this formula, so here the percentage change in quantity is greater than 10% over percentage change in price, that is 10%. So price elasticity of demand is equals to, you can say it is greater than 1. Next is perfectly elastic demand, the other extreme. A demand curve that is horizontal, this one. Consumer price elasticity is extreme. Elasticity is, you can say, infinity. Price changes by 0% and quantity changes by any percent. Extreme price sensitivity means the tiniest increase causes demand to fall. Here you can say quantity changes by any percent. When the demand curve is horizontal, the quantity is indeterminate. Consumers might demand quantity, you can say Q1 units 1 month, QU units in the other month, and some other quantity later. So quantity can change by any amount, but price always changes by 0%, that it doesn't change. If perfectly elastic is one extreme, this perfectly elastic is the other extreme. Here is a good real world example of a perfectly elastic demand curve, which foreshadows an upcoming chapter on firms in competitive markets. Suppose you run a small family farm. Your main crop is wheat. The demand curve in this market is downward sloping, and the market demand and supply curves determine the price of wheat. Suppose that the price is $5 per bushel. Now consider the demand curve facing you, the individual wheat farmer. If you charge a price of $5, you can sell as much or as little as you want. If you charge a price even just a little higher than $5, demand for your wheat will fall to 0. Buyers would not be willing to pay you more than $5 when they could get the same wheat elsewhere for $5. Similarly, if you drop your price below $5, then demand for your wheat will become enormous, not literally infinite but almost infinite. If other wheat farmers are charging $5 and you charge less, every buyer will want to buy wheat from you. Why is the demand curve facing an individual producer perfectly elastic? Recall that elasticity is greater when lots of close substitutes are available. In this case, you are selling a product that has many perfect substitutes. The wheat sold by every other farmer is a perfect substitute for the wheat you sell. So if we add these values in the formula given here, uh, we have that percentage change in quantity is, you can add any of the value over percentage change in price, that there is no price change. That means that price is constant here. P1 is equals to P2. Price changes by 0%. So price elasticity of demand is infinity. Now comes elasticity of a linear demand curve. The slope of a linear demand curve is constant, but its elasticity is not. Here E is the abbreviation for elasticity, and more specifically the price elasticity of demand. Calculations of percentage changes use the midpoint method. That is why the increase from Q0 to Q20 is 200% rather than infinity. As you move down a linear demand curve, the slope, that is the ratio of the absolute change in price to that in quantity, remains constant. From the point 0 uh, and $30 to the point 20, this one, and $20, this point. If you can say that from this point to this point, the rise equals minus 10 and the run equals plus 20. So the slope equals minus 1 by 2 or minus 0.5. And from this point to this point, the rise again equals minus 10 and the run equals plus 20. So again the slope equals to minus 0.5. However, the percentage change in these variables does not remain constant, as shown by different colored elasticity calculations that appear on the slide. So here from this point to this point, the elasticity is 5, and from this point to this point, elasticity is 1. That is, you can say unit elastic, and from this point to this point, elasticity is equals to 0.2. The lesson here is that elasticity falls as you move downward and rightward along a linear demand curve. So as you can see that elasticity is falling as you move downward along the linear demand curve.